So this section is dealing with quadratic equations. So first, let's discuss what is a quadratic equation here. So a quadratic equation is an equation of the form ax squared plus bx plus c equals 0. Okay. Now we're going to go about solving these in a few different ways, but first, before we do that, let's discuss, well, previously we could distribute when we had a coefficient that's being times a group. Now we can actually extend that to if we have larger things being multiplied by each other. So for example, x plus 2 times x plus 4. Now for this, what I'm going to do is I am going to distribute the x to both of these first. So x times x is x squared. X times 4 is 4x. Now after I've distributed this x to both of these, now I distribute the 2 to both of these. 2 times x is 2x. 2 times 4 is 8. Okay. Now I'll just combine like terms. X squared plus 4x plus 2x is 6x plus 8. And there we go. So whenever you have something like this, you can just distribute your first to all of these and then your second to all of these. Now what if I had x plus y plus 4 times x minus 3? Same thing here. I just take x times x, I get x squared. X times negative 3 is negative 3x. Now that I've distributed y to both of the, or x to both of these, now I move on to y to both of these. Y times x is xy. Y times negative 3 is negative 3y. Then we move on to the 4. 4 times x is 4x. 4 times negative 3 is negative 12. Then we combine like terms. X squared, then negative 3x plus 4x is plus x plus xy minus 3y minus 12. And there we go. Okay. So again, all that we're doing for these is just distributing. If you can remember how to distribute and remember to distribute every part of your first one over to your second, you'll be fine. Okay. So now, let's go ahead and talk about how we can FOIL particular expressions. Okay. So we're going to be factoring these type of quadratics, but the first case we're going to do is when we're factoring ax squared plus bx plus c when a equals 1. Okay. So let's consider when I have x squared plus 8x plus 15. Okay. So note here the coefficient for a is 1 because we don't see anything here. So now to factor these sorts of ones, we just start off and we know the first term on each of these is going to be x. Okay, so we get that for free. So then what we do here is we check what are the factors of 15 that add to give me 8. So for example, 3 and 5, because 3 times 5 is 15 and 3 plus 5 is 8. Now just a little thing to note. Whenever you get a pair, you also get the opposite of that pair. So if you get the right magnitude, but it turns out that your sign is different, if you needed a negative and you had a positive or vice versa, that tells you just need to use the opposite pair. Okay. So here, I can just write this as x plus 3 times x plus 5. Okay. So we're just looking for the factors of 15 that add to 8. Okay. Let's do another one. Let's suppose I give you x squared minus x minus 90. Okay. Now, if you're factoring this, or any of these for that matter, and you can't quite figure out where to go, you can just choose 2 factors that you know work. Okay. So I might just try, for example, 3 and negative 30. Now, 3 times negative 30 is negative 90, and 3 minus 30 is unfortunately negative 27, which is not negative 9. So here's my little hint for you. If when you combine these, the magnitude is too small, then they need to get further apart. That is to say, your smaller number goes down, your larger number goes up. If the sum or difference in terms of magnitude is too large, then these need to get closer together, which means that this 3 goes up and this would go down. So for example, I might say, well, 3 doesn't work, 4 doesn't work, 5 works, so 5 and negative 18. That gives me negative 13, which doesn't work, unfortunately. So then I can move to 6 and negative 15. 6 minus 15 is negative 9. Darn, that also doesn't work. 7 doesn't work. 8 doesn't work. 9, what about 9? 9 and negative 10. Hey, 9 minus 10 is negative 1, so I found it. So it's x plus 9, x minus 10. Okay. So for these, you'll note that if you can't find them, you can go ahead and do a methodical process just by noting, hey, if it's too small, this number needs to keep getting bigger, and keep doing that until you get to your number. Okay. That way you can have a precise way of doing this without just jumping from factor to factor as some students like to do. Okay? It really takes the guesswork out of this and makes it a lot more straightforward. Okay? Let's do another one. X squared minus 7x minus 44. So we need to figure out what multiplies to give me negative 44 and adds to give me negative 7. So I'm going to do the same trick I just got done doing over here. Even though I know what the factors are going to be, let's suppose that I don't. So we have 2 and negative 22. When I combine these, I get negative 20. I need negative 7. The magnitude is too large, so these need to get closer together. 3 doesn't work. Well, what about 4? 4 times what is negative 44? Well, negative 11. 4 minus 11 is negative 7. So we see that that's actually what we're looking for. So x plus 4 times x minus 11. And that's it. Okay. So you'll note factoring when a equals 1 is pretty straightforward. You're just looking to factor c and figure out what adds to give you b. Okay. Now, unfortunately, we do not always get these nice, easy cases. So now, let's go ahead and handle factoring ax squared plus bx plus c when a does not equal 1. Okay. For this, I'm going to be making use of what's called the AC method. Now, the AC method is not one that you will find in your textbook, so if you want to see more examples, please let me know. Alternatively, you can find more examples on Khan Academy. So you can just Google Khan Academy AC method, and they'll have a bunch of examples there for you as well. Okay. But when we're doing this, the name AC method comes from the fact that you take A times C. So let's go ahead and just take a look at one here. Let's say we have 3x squared plus 7x plus 2. So the first thing I do is I take 3 times 2, which gives me 6. So I want factors of 6 that add to 7. Well, we can see that that's 6 and 1. Now, unfortunately, we can't just move to the end. Instead, what we're going to do is we break up this 7x as 6x plus x. So it becomes 3x squared plus 6x plus x plus 2. Okay? So our whole goal was to get it from 3 terms into 4. Well, great, we've got it into 4 terms. Well, now what? Well, now we factor by grouping here. So we take one group of 2 and one group of 2. So we ask, what factors do these share, if anything? Well, the coefficients, 3 and 6, they share a 3. X squared and x, they share an x. So I'm going to factor that out. 3 divided by 3 is 1. X squared divided by x is x. 6 divided by 3 is 2. X divided by x cancels, so I get x plus 2 here. Plus, do these share anything? No, they don't. So this is just x plus 2. Now we'll note, what factors, if any, do these share? Well, they share x plus 2, so I can factor out x plus 2. When I do that here, I'm left with just 3x. Plus over here, if I factor out an x plus 2, then I factored everything out. Now remember, when you factor out everything, it doesn't give you 0, it gives you 1. So I get x plus 2 times 3x plus 1. Don't worry, we'll do more examples. Let's do another one here. 2x squared minus 17x plus 30. 2 times 30 is 60, so that's our first step. Now we want the factors of 60 that give me negative 17. Well, since this is positive and this is negative, we know we're going to need two negative factors. So I'm going to see that it's negative 5 and negative 12. Hopefully everybody sees that, because negative 5 minus 12 is negative 17, and negative 5 times negative 12 is negative 60, which is what we're looking for. Okay. So now I break this up. 2x squared minus 5x minus 12x plus 30. So now I'm going to start here with this grouping and then this grouping. What do these share? They share an, oh, this should be plus 30, of course. These share an x. So that gives me 2x minus 5. Now over here, what do these share? Well, these share a 6. Now, one thing you want to note here, this 2x is positive and this is negative. If that's the case, we need to factor out a negative to make sure they have the same sign. So here I factor out negative 6. Negative 12x divided by negative 6 is 2x. 30 divided by negative 6 is negative 5. So now, what does this have in common with this? Well, they have 2x minus 5. When I factor out the 2x minus 5 here, I'm left with x. When I factor out the 2x minus 5 here, I'm left with negative 6. And there we go. Let's do another one. 8x squared plus 33x plus 4. 8 times 4 is 32. So we need what multiplies to give me 32 and adds to give me 33? Well, fortunately, it's just 32 and 1. Okay. Now you could have done 1 and 32. I should note the order in which you put these doesn't actually matter. It'll turn out the same either way. So I rewrite this 8x squared plus 32x plus x plus 4. Again, just noting that the 33x became 32x plus x, because when we add these up, we get 33x. Okay? And we'll see that for this one as well. Okay. So now, factor by grouping. What do these share? Well, 8 and 32 share an 8. X squared and x share an x, so I factor that out. 8 divided by 8 is 1. X squared divided by x is x. 32 divided by 8 is 4. X divided by x cancels, so I get x plus 4. Plus, what do these share? Bupkis. They share nothing. So that leaves me with x plus 4. Well now, what do these share? They share x plus 4. And I'm left with 8x plus, well, I factored out the x plus 4, that leaves me with 1. There we go. So this is the AC method. Okay. Now I'm actually running out of time for this video, so what I'm going to do is record a second video where we're going to start talking about how we can use factoring to solve quadratic equations, and then we're going to make use of the quadratic formula and go from there. Okay. Let me know if you have any questions, you want to see any more. Otherwise, I will see you in part 2.